Hi, in this lesson we will be teaching transformations of quadratic functions. So remember we've already studied quadratic functions. We've studied standard form, vertex form, and factored form of quadratic functions. We know that quadratic functions graph as a parabola. So when we talk about graphing transformations of quadratic functions, we are transforming them based on what we call the parent function. So think parents sometimes have babies, and babies resemble the parent. So all parabolas will resemble the most basic parent function, y equals x squared. That is the most basic quadratic function. Next, I've got here transformation form or vertex form. So the form we're going to be looking at is equations in vertex form. This is the form that helps us to transform our function. So remember, vertex form is y equals a times the quantity x minus h squared plus k. We already know that our vertex is hk, so I'm just going to put a little reminder here that our vertex is hk, and that we have to remember to switch the sign of what we see in here. So if we see minus 5, we would write down a positive 5. So remember, switch keep, just like we did when identifying the vertex in vertex form. So this is the form we're going to use, but of course, for our parent function, we need to know the graph of the most basic parent function. So we've done this before, but I'm just going to, as a reminder, if we graph y equals x squared, then our y values will be found by squaring our x values. So the most basic ones we generally include are the ones near the origin. If we square negative 2, we get 4. You might think, she's already done this before. If we square negative 1, we get 1. If we square 0, we get 0. If we square 1, we get 1. If we square 2, we get 4. So this leads to 5 basic order pairs we should understand about the quadratic function. The vertex is going to be here at the origin at 0, 0. And then we can go out 1, up 1 to graph 1, 1. And from the vertex, left 1, up 1 to graph negative 1, negative 1. From the origin, we can go right 2, up 4, because 2 squared is 4. We can go left 2, up 4, because negative 2 squared is 4. And it would continue on like that. So 0, 0, out 1, up 1, out 2, up 4, out 3. Can you predict that? Out 3, up 9, out 4, up 16, out 5, up 25, etc. So please make sure your graphs extend all the way to the end of your graph paper. I will have this attached as well as a picture of the notes if you would prefer to print those out. But certainly you need to write this in notes in a notebook if you do not have the capability to print. So just sketch an XY axis if you don't have graph paper and plot these points. But make sure you're including your table. So when we check for notes, I want to see this table for the parent function as well. So next we're going to talk about vertical shifts. So if we have the quantity x minus 2 squared, we should recognize that our a value is an understood 1. And we'll talk more about what happens when it's not 1 tomorrow. And remember, if I asked you to identify our vertex here, you would probably go, well, I know we switch what's in parentheses. So that would be 2. And if you don't see anything on the outside, it's a 0, or else you would see a number being added or subtracted. So really what happens is whatever happens in parentheses results in a horizontal shift. See how this says h, the quantity x minus h? Think h for horizontal. And k for vertical. And actually I totally just wrote those in the wrong spot. So I'm sorry, I'm just going to go up here and change this vertical to horizontal. And down here change this to vertical. So please forgive me. If you printed this out, make that change, but the copy you use, if you make copies, it'll be correct, okay? So this will be a horizontal shift. So I want you to recognize that anything in parentheses is going to shift horizontally, which is left and right. So if I see minus 2, oftentimes our brain thinks minus means I go left because my x values are negative, but actually it means the h value is a positive 2. And to get to that point, I would shift right 2. So that would mean that our horizontal shift based on this equation is right 2. So that means I'm going to take this parent function and copy it, but I'm shifting the vertex and every other point right 2. So to graph this, our vertex is at 2, 0, again from switch keep. And I'm going to go out 1, up 1 on either side, back to the vertex, out 2, up 4 on either side. And I have now shifted my parabola, this parent function, I have shifted it right 2. So remember, whatever's in parentheses is the opposite of what we see. If we see a -2, it really means the h value is a +2 for our vertex hk, so it's going to make us shift right 2. So next I'm going to talk about if we have a vertical shift. So this means if I do not see the parentheses, technically we can think of this as x minus 0 quantity squared. Then that means our vertex is not going to shift horizontally at all, but it is going to go down 3. So 0, -3, which means vertical meaning up and down, we would shift down 3. But what are we shifting down 3? We're shifting the graph of the original parent function. So notice the difference. I've got y equals x squared, and here y equals x squared minus 3. It just means I'm taking this x squared function and shifting it down 3 because I've got a -3 on the end. So that means I'm going to go from my origin down 3 to start. That's where my vertex is going to be, 0, -3. Remember, x minus 0 is just x. That's why we can write x minus 0 squared is just x squared. And I'm still going to do the same thing I did before, meaning I'm going to go out 1, up 1, out 2, up 4. And I can even, I think, fit out 3, up 9. Let's see, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I can, right here. So again, out 3, up 9. So all I'm doing is taking this parabola y equals x squared and shifting it down 3. Feel free to pause at any time to catch up and get these notes. So now that we understand that, let's do a quick another example. You can see I've got an extra example written down here. So if I have y equals the quantity x plus 5 squared, what does that mean I'm going to do? Well, positive makes us think to the right 3, but we actually are going to go left 3, because remember we have to switch and keep. So if my vertex is at -5, 0, I'm going to end up shifting left 5 from the origin to get to this point. With this extra example down here, y equals x squared plus 2. If it was -3, I shifted down 3, and again, that's because we switch keep. So we're going to keep the sign if it's not in parentheses. So a plus 2 would mean my vertex is at 0, +2. So think about if I was at the origin, how would I get to 0, 2? I would shift up 2. So when you do your work today, you are going to turn in a list of what the functions were and how they are transformed. But you're going to practice graphing them. It's nice on Delta Math. You're just going to drag a graph around. The last vertical reflection we're going to talk about today, or last transformation we're going to talk about today is called a vertical reflection. So remember, vertical again means up and down, but this specifically has to do with the a value. So we already know that if we have a positive a, it's going to open up, and a negative a is going to open down. We've already covered that. So if I am looking at y equals -x squared, so remember, think about what that means. In standard form, it means you don't have a linear term or a constant term, but my a value is a -1. So here, if my a value is -1, it's going to open down. So what that means is, and I'll do my original y equals x squared in blue. So 2, 4. So if this is y equals x squared, then y equals -x squared just means I'm going to flip it down. So I'm going to keep 0, 0. This -1, 1 comes down to here. So we're basically flipping it over this x-axis right here. We're just flipping all of our points. All the y values after x is squared, we multiply by a negative, so our y's become negative. So negative 2, negative 4, 2, negative 4. When I connect it, this is y equals negative x squared. So like I said, I'll be taking a picture of this and uploading it to Canvas as well. But I do need you to write it down. So to submit notes today, you will either need to write it in a notebook. You will need to either print the blank copy and fill it in like I have. But you have to do one of those two. Either copy it down or print out the blank copy and write it down. But if you want to, for your own reference, take a picture, then you may do so. But you are getting a grade for turning in notes today, okay? So let's go ahead, and I have one more sheet where we're just going to do the graphs of 4 examples and start combining all these horizontal shifts, which means in parentheses I go left or right, and my vertical shifts, which means I go up or down according to the sign of the constant at the end. Or if it's negative, I may end up flipping it down. So we're going to take all those concepts and do that now. So to graph y equals the quantity x minus 4 squared minus 1, I have to recognize that whatever I have in parentheses, I think about the opposite. So if my x-axis goes left and right, and if I think minus 4, my brain needs to switch that to positive 4, meaning I'm going to go right 4. For the constant here on the outside, the plus k, that indicates my vertical shift. So if I see minus 1, it is what it is. If I see minus, I'm going to go down. So I'll put up here that if you have a positive k, you're going to go up k. And a negative k, you're going to go down k. And where does k come from? I have it written right here again, that k is the constant here at the end of your function. So that's down k, by the way. It's hard to see. All right, so if I have minus 1, that means I'm going to go down 1. So today, when you do this in Delta Math, you're going to write down the function, and then beside it, you're going to simply list your transformations just like this. Okay, so I'll give you an example and show you how that's going to work because I'm going to practice some with you. So that means from the origin, I want to go right 4, down 1, which to be honest should make a lot of sense because we already know from vertex form, if I ask you to identify the vertex and I tell you to switch keep, what is it? It will be 4, negative 1. So we're really just making a connection to what we already know, which is identifying the vertex, to understanding this shift. But this is important because you're not only going to study quadratic functions and their transformations, but in Math 3 and Math 4, you study tons of different types of functions with these very same types of transformations. So these concepts of explaining left and right and up and down and whether things reflect, and including what we're going to teach tomorrow, all of it will apply for transforming functions in your Math 3 and Math 4 courses. So because my a value is a positive 1, it tells me it's going to open up. So this means I'm going to go up 1, or out 1, up 1 from either side, and then out 2, up 4. So we are always modeling what we know to do on the parent function, which is from the vertex, we plot our vertex, and then we go out 1, up 1, and then out 2, up 4, and if we have room, we could go out 3, up 9. Okay? And that's really all there is to it. And we're just going to connect it and make sure it's long, and we always put arrows to show that it goes up forever in this case. So again, from the origin, my vertex, switch keep, is 4, negative 1. And then I'm going to continue this pattern, which is this same exact pattern here. So actually, I probably should write it here. So if you want to flip back to your front page, first thing you do is plot the vertex. Then you go out 1, up 1. And that means out left and right. And then we go out 2, up 4, out 3, up 9, etc. if we're able to fit all those points. All right. So let's take a look at example 2. So example 2, first thing from left to right that I notice is I have a negative. I also have something in parentheses, which I know affects my horizontal shift. So if I go back to the front part page of my notes here, then minus 2 means I went right 2. So what do we think plus 1 is going to mean? That should mean we go the opposite of plus 1, which would be negative 1. And on the x-axis, going negative means we go left. And then if I don't see a constant out here, then I understand it's nothing. It's a plus 0. So again, it may be very helpful for you to go, what is my vertex? If I switch keep, I have negative 1, 0. So how does all this play into listing my transformations? Well, if I have a negative, I need to write vertical reflection. You will sometimes see this in other videos, and sometimes I'll do it. It's a reflection over the x-axis, or you can say vertical reflection. If you prefer to say reflect over x-axis, that's fine. But this is a vertical reflection, and we also are going to shift the opposite of plus 1. We're going to go think minus 1, and that means we go left. So we're going to say left 1. If you have trouble with this, then graph it first, then write this. Because this means if I know from the origin that I'm going to go to negative 1, 0, which is right here, then didn't I just go left 1? So plot your vertex first, and then you can list left 1. And then if it reflects vertically over my x-axis, that means I'm going to go out 1, down 1. And then out 2, down 4. And then connect. So maybe for this negative on the front page for y equals negative x squared, we could do the same thing. We plot our vertex, and then we go out 1, down 1, rather than up. Then out 2, down 4, rather than up 4. So that's what a negative is going to do. It's just going to take that parabola and flip it down, flip it over our x-axis, okay? So example 3, here I have an understood positive 1 as my a value. So it's going to resemble y equals x squared, but my vertex is switch, keep, negative 2, 1. So that means from my vertex, I'm going to go down 2, up 1. And because my a value is 1, I'm going to follow this same set of steps here. I'm going to go out 1, up 1 from my vertex, out 1, up 1. And that means out left and right from my vertex. Out 2, up 4, out 2, up 4. Oops, did I go 3? 1, 2, 1, 2, 3, 4. Oops, that should be here, not here. So when I connect it, just make sure I go through this point. So exactly why we should be using a pencil, right? Miss Robinson should be using a pencil, not a pen. And that would be how I graph it. But remember, you also have to list your transformations, rather. So just think, how did I get to this point? I went left 2, up 1. So that's what you would need to write. Left 2, up 1 as your transformations. That's it. So like I said, it does, I think, make it a lot easier to identify the vertex first. But we don't always have a vertex on certain graphs, so we have to recognize that whatever happens inside a grouping with x actually affects that shift in the opposite direction of what our brain might think. So again, my vertex here, switch, keep. And what happens because I have a negative? I'm going to have a vertical reflection. So I'm going to list that first, since that's what I come across first when I read it from left to right. Vertical reflection. And then how do I graph it? From the origin, I'm going to go left 3, up 1. And then, because my a value is negative, I'm going to go down. So exactly what we did here for y equals x squared is what we're going to do. From our vertex, we're going to go out 1, down 1, out 1, down 1. Then out 2, down 4, out 2, down 4. And that's it, guys. So that's how you graph it. But what do we need to add to our list? So we have a vertical reflection because of the negative. And just think, how did I get from 0 to the point -3, 1? I went left 3, up 1. And that's all you have to do. Left 3, up 1. All right. So if you are still listening at this point, please put a star in the bottom right corner of your notes. If it's in your notebook, just wherever the bottom right corner is. And now we're going to go straight to Delta Math, and I'm going to show you exactly what you're going to need to submit for, and if you would, just submit it with your notes, okay? Submit your work and notes together today. So I'm going to go here to Delta Math, and there are 21 problems, and I'm going to be doing 8 of them with you. And this is actually a really easy process. If you notice, I also have Desmos up, and that's just for like if you are having trouble graphing it, if you're not feeling very confident. Remember that Desmos is always a great tool, or you can use the Calculate 84 app on your phone and just simply go to y equals and type your function in. So I have that up just to remind you that you can use Desmos if needed. But if you're not sure, if you want to try it over here, or if you want to maybe try the problem and then verify the graph before you're hitting submit, that's fine too. You are going to get 3 attempts on each one. So I'm going to go here to problem 1, and we're looking at y equals the quantity x plus 5 squared. So right after your notes, or just make sure on a clean sheet of paper you write down that this is, what is today's date? Today's date is 10/8/20, and this is Transformations Day 1. Transformations Day 1. I'm writing this on notebook paper, and I'll show you in a second. I'm actually going to, because I don't really need Delta Math, I just wanted to show you that it's available. Excuse me, I'm going to slide this over and just show you exactly what I want you to write in terms of work, and we're going to be looking for the work plus the notes, or the 2 papers that you printed out and wrote on plus these answers, okay? So number 1, and you're going to need to write down every single problem, but it's not a lot of work you have to show. So y equals the quantity x plus 5 squared. Refer back to your notes, so keep these notes handy. So what happens if it's in parentheses? We're going to shift the opposite of what we're thinking, right? So if I see minus, I'm going to shift right, but if I see plus, and look, I already did this one for you in your notes. If I see plus 5, I'm going to shift left 5. So I'm going to take this function here and take point on my vertex and drag it left 5. So 0, if I go left 5, look what happens. I can pick up the whole function and move it. So I moved it to -5, 0. If you wanted to go over here and go, okay, did I do that right? Then you could always type it in. And yes, you did. Okay? But please try it first, then verify it. Try it first, then verify it, because you need to not rely on the calculator to explain this. Because like I said, when you get to Math 3 and 4, you're going to be doing transformations all the time, and you've got to be able to just spit them out. So x plus 5 quantity squared, I believe our graph is correct, so I'm going to hit submit. It looks good. You can even see that it says shift left 5 units. And we verified it, and in my notebook here, I'm going to just come over here and write left 5. That's all I need you to do. Take every function and write what the transformation is. Hope that's easy enough. So like I said, I'm going to do, I think I've got 8 that I'm going to do with you. So next, if we take a look at this, now I have y equals the quantity x minus 5 squared. And remember, it's going to do the opposite. If it's on the inside, remember, switch keep. So this would be right 5. Now, if you want, if you're comfortable with saying, okay, let me write the vertex for everyone because that makes the most sense to me, cool. Write your vertex for all of them. In fact, let's do that. Let's make sure you, in your notes, always write the vertex for these as well, or in your work. That's going to be really important. So now that I know I'm going to go right 5, I'm going to take this and shift my parabola, right 5. Make sure it sits on 5, 0. So notice again, minus, I'm actually going to shift positive in a positive direction. And if it's plus in parentheses, I'm going to shift it in the negative direction. And that's good. But remember, like I said, you could always go to Desmos and just change it up here. Remember, guys, by the way, if you haven't caught on yet, you can hit these 2 arrows and then that'll disappear and you can see better. And then you can always make it come back. Okay? So number 3, that's done. So I'm going to go on to number 3. Now I'm going to do number 6 next. So the next couple are just left and right shifts. So if you want to pause and try those, you're welcome to do so. I'm going to go ahead and move on to number 6. So 3, 4, I'll leave space here, 5, 6 in my notebook. Number 6 is y equals negative x squared. Well, guess what? We already did that one. And we know that it is just a vertical reflection. But again, remember, you could also say reflect over the x-axis. Okay? So to do a vertical reflection, and the reason why I chose this problem is I want you to practice. You can take any of these points either on the left or the right side. And remember what we said. Instead of going out 1, up 1, we would go out 1, down 1. So I'm going to take this point at 1, 1, and I'm going to drag it. And look what happens. It flips. So I'm going to drag it to the point 1, negative 1. And I should be good to go. So now I've got 2, negative 4, 3, negative 9, etc. Like I said, if you just want to go over here and say, I'd feel more comfortable if I type it in first. Before hitting submit, there you go. You can see that that's correct. Hit submit answer. And we're good to go. See, it says reflect over x-axis, so you can call it a vertical reflection or say reflect over x-axis. Both of those would be correct statements. All right, I'm going to try number 7 now because we're actually going to mix this up a little bit. So in your notes or on your paper, make sure you're writing this problem down for number 7. So by the way, here the vertex was 0, 0. For number 7, if I have y equals negative x squared minus 4, you got to remember there's nothing in parentheses, and when there's nothing in parentheses, that means that technically it was, you don't have to write this down every time you do it, but I just want you to see that when there's nothing going on in parentheses, that means there is no horizontal shift. This minus 4 is our vertical shift, meaning we go down 4. So switch keep, 0, negative 4. I'm keeping that negative 4. So think about what that means for this graph. It means because of this negative, I have a vertical reflection. If you want to just say x-axis reflection, that's another way to put it. Reflect over the x-axis reflection, vertical reflection. Either of the 3 would be fine. But remember, to get to 0, negative 4, we would need to take this point here at the origin, this vertex here, for our parent function. And we're going to drag it down 4. But that's not enough. We have a vertical shift down 4. So I'm just going to come over here on my paper and write down 4. But I'm also going to take any one of these points and flip them. But I think the easiest one is to take this out 1, up 1, and just move it to out 1, down 1. There you go. But again, if you want to type that in here and just do the minus 4, you can go to here and see it's 0, negative 4. That's our y-intercept, our vertex also. And we're good, so we're going to submit. So remember that in addition to graphing, and you can see when you do it, it tells you the correct answer. So in your notes, is there any reason why you should not get these correct? No, because whether you get it right or you get it wrong, it's going to tell you the answer. I hope you're listening. It's going to tell you that it reflects over the x-axis and you shift down 4. So please, please, please write this down and have these examples in your notes, because if not, when you go to take your quiz and test next week, you might not remember it. And we don't want that. We want you to have plenty of examples. So we are next going to do 8, because now, notice I have a negative here, but now I have a horizontal shift here in parentheses. So in my notebook, I'm going to write, okay, now I'm on problem 8. I have a negative, so that's an x-axis reflection. or whatever your preference is, the vertical reflection, reflect over the x-axis. And we're going to think about that vertex. So remember, if you don't see anything on the outside, that means there is no vertical shift. So that would be a +0. And therefore my vertex is switch keep, +5, 0. So I want you to think, okay, so that -5 means I'm going to go right 5. So I'm going to take my vertex and drag my graph to the right 5. And because of my negative, I'm going to take this out 1, up 1, and change it to out 1, down 1. All right, again, feel free to type it in there if you need to. I'm going to submit my answer. And I'm good. So that is number 8. I'm going to do number 10 with you. So I'm going to leave space in my notebook for number 9 and skip on down to 10. And in my notebook, you need to have the equation, guys. This is what's going to help you when you take a test or quiz, because the big deal is you've got to not just be able to graph them, but list your transformations. So on number 10, I've written that down in my notes. Y equals the quantity x minus 3 squared minus 4. And identify that vertex, guys. That's always going to help you. So it's a positive understood 1 here, so there is no x-axis reflection. So all I have to do is switch keep. So 3, -4, which tells me that I'm going to go, to get to the point -4, I'm going to go right 3. So I'm going to take my parabola, pick it up, and go right 3. And then I have to go down 4 to get to 3, -4. And I'm just going to place my vertex right there at 3, -4. So this, then in your notebook, all you have to do is come over here and say that you went right 3 units and down 4. That's it. Notice we're not saying down -4. Don't do that. The negative just tells you the direction. A negative value for the x means left. A negative value for the y means down. A positive value for the x means right. A positive value for the y means up. That's really all there is to it, guys. So you're going to do a few more to practice those. And lastly, I'm going to go over numbers 16 and 17, because on 16 and 17, I need to fix that. Hold on. Drag my 9 back up here. I might need to number that. I don't know. I'll fix that before I post it. So 16, I'm going to go to 17. And now I'm asked, the graph of x squared is the solid black graph below. Which function represents the dotted graph? So they're giving you your parent function, and they're asking you, how does this red dotted function compare to my graph here, to my parent function? Well, I know that it opened down, so I'm going to go in my note. I need to flip my page in my notes here. So if 16 is going to end up being a little bit down here. So if I'm on 16 and I know that it opens down, I need a -a because I have a x-axis reflection. And I also know that my vertex is the ordered pair -3, 0. So if I'm trying to identify the function, and I know that I have to have it in transformation form, or also known as vertex form, y equals a times the quantity x minus h squared plus k, then my a value is going to be negative here. I am going to switch and keep to plug in for h and k. So that means my function would look like y equals negative, just an understood 1, because it's still out 1, down 1. And then times the quantity x, and if I see -3, I'm going to switch it to +3 squared. And I do not need to put a +0, so I am looking for this equation down here for my multiple choice options. Now for these problems in your notebook, my recommendation would be make a list of your transformations and write the function like I did here. But you may be able, like I said, if worst comes to worst, you could always go in here and type in your answer choices and see which ones match, right? So we would never want to get these wrong. but I'd be looking for the negative on the outside and the one that shifted right 3. And that would be here. So when I look at all these options, they don't all do that. This is a x-axis reflection right 3. This is an x-axis reflection, excuse me, did I say that right? You're not going to choose this one. This is left 3, so that's right 3, that's left 3. This, when it's on the negative, when the negative is on the inside, it actually means there's a horizontal reflection or a y-axis reflection. But we don't have to do any of those in this course. This would mean it goes down 3. This would be a y-axis reflection and up 3. So since we want left 3, we already put it in our notes, we're going to choose this one. So even if you get it wrong, guys, you need to write down maybe the transformations. Like, see how it's explaining right here and showing you? I love these problems. So again, you've got your original equation, you reflect it over the x-axis, and you translate it left 3. So remember, it even tells you here, remember to do the opposite of what you see. If you see plus 3, you need to think negative 3 and go left 3. I love delta math. So is that 16 or 17 that I just did? That was 17, actually, that I just did. So I need to change that in my notebook. That was 17, and we're going to do 18. I apologize for that, guys. So we're going to do 17 and 18. So now take a look, and I'm going to put this down in my notebook. Let me switch here. 18. Let's see. What do I see when I look at the graph? I see that I have an x-axis reflection or vertical reflection. So I'm going to write that down. And I see that it went right 2. So that means my vertex is 2, 0. So this is what I wrote down. X-axis reflection. It went right 2, and my vertex here is 2, 0. So again, x-axis reflection, I'm looking for the negative on the outside, so that's one of these two. And if I want right 2, I need to look for a negative 2. So that's going to be this one here. But remember, you can always go in here and type it in. Once you narrow it down, you might want to do that if you're not very confident yet. So this one, again, is right 2. This one is left 2. So I feel very confident about that. I'm going to go ahead in my notebook and write that down, that I chose y equals negative. You actually read it as the opposite of the quantity x minus 2 squared. Okay? Feel free to take pictures of these if you want to for your phone, so that next week when we're doing these types of problems on a quiz or test, you'll be like, oh yeah, I got all these pictures I can look back at. So do that if you like. I'm going to go ahead and hit submit. And that about does it, guys. So just as a highlight for 19, I'm going to drag that 9 somewhere else. Actually, let me see. Yeah, I actually need to drag this 9 up here. That somehow got out of order. Sorry about that. And then, so I did 17 and 18 for you. 19, if you just take a look at that, guys, you're not only moving it left or right, you're moving it up and down. So this one, if you think about it, you're going left 2, down 5. So which one of these means left 2, down 5? All right. So good luck with that. Let us know if you need any further help. You have 13 problems remaining to do on your own. Make sure that when you finish, you submit a picture of the notes plus a picture of the work. So I should see at least a good 2 pages for your graphs. And it's going to take me, and you know, I'm kind of writing like this in a notebook. So this page and a piece of that page to finish up. So basically 2 pages, but I'm really just writing down problems, and you have to describe the transformations. That's what we're looking for in your notes, for you to describe those transformations. All right, guys, good luck.